All units stand 3. It now appears as though shots are being fired. All officers use caution. It has been confirmed. Suspects are armed and are firing at police.
60 on the air. Northwest Signal 10. Building fire. Headquarters. Northwest Signal Fire Department. 1000 North Broadway. Towards North Park Drive in North Albany.
Multiple explosions coming from 661. Unable to get any ambulance, any reach out except for 667. Automatically go to a third alarm.
Welcome to Scanner School. This podcast is here to teach you everything to know about the scanner radio hobby. My name is Phil Lichtenberger. My amateur radio call sign is W2LE, and my GMRS call sign is WQXJ920. Today, we are talking about what happens when trunk systems fail. A really quick podcast episode because there's not a lot to unpack here. It's a very interesting topic, though. Trunk systems are built around a computer backbone with a lot of interconnecting parts. You have IP links or microwave links or telco links, right? What happens when something fails? What happens when you have a power outage, a lightning strike, the database gets corrupt, right? All these things can break a trunk system, but we still need to have radio communications with units on the field because we got police officers, firefighters, EMS personnel. You've got people who are in life-saving operations here, bringing people who are sick into hospitals. They need to be on that trunk system. And when the trunk system fails, they still need to be able to communicate. How do they do that? And we're going to talk about that on today's podcast. But before we go any further, I need to remind you that I need questions for our next upcoming Ask Scanner School podcast episode. You can leave me a voicemail at 516-308-2885, or you can go to scannerschool.com/ask, and you can press the speak pipe button. If you leave the speak pipe voicemail or our 516 voicemail, I'll put you in running for a free tutoring session. Or if you're a little mic shy, you can just leave me a message on the form on our Ask page, and we'll get it answered on an upcoming Ask Scanner School podcast. Now, before we get any further in this week's podcast, I want to take a few minutes to thank our Patreon supporters. Now, Patreon is an affordable way for you to support the podcast and our upcoming expansion into YouTube for 2022. So think of Patreon as the PBS model of helping out Scanner School. For a monthly or yearly donation, not only do you help support the podcast, but depending on your donation tier, you will receive certain benefits. The most popular benefit tier being our $5 a month or the $51 a year tier. It's the same tier. We just discount if you can pay us over a year. Now, this tier offers the podcast and YouTube videos early, and also you receive a free Squelchy pack of stickers, several discounts, and access to our monthly live Scanner Radio Roundtable discussion we hold monthly on Zoom. Oh, and by the way, most of the Patreon levels also get a special version of the podcast that does not include the middle advertising break in each episode. Now, find out more about Patreon and our supporting tiers by visiting scannerschool.com/Patreon. I'd also like to take a moment here and thank all of our Patreon supporters. Alan Gonzalez, Arthur Heron, Bill K., Bob Milton, Brandon Sammons, Brian King, Chris Paris, Craig Harper, Dan, Dave Pasco, David C., Denny Crotty, Ed Walsh, Edward Bramlett, Glenn Wright, Greg Johnson, Guy Lee, Jack Haycock, Jacques Berry, James Broxson, James Felling, James Peruta, Jay Reed, Jeff Block, Jeff Chapman, Jeff McLeod, Jenny Taylor, Jim B., Jim Heinrich, Joe Curtis, Joe Kordoff, John Keel, John Sweeney, John Goldenberg, Joshua Robb, Kelly Wilkins, Ken Newberry, Kenneth Fowler, Kevin Zwicky, Lenny Bauer, Les Stevenson, Lloyd R., Mark Beebe, Mason Kramer, Michael Gorman, Michael Kroger, Mike Lopez, Nicholas Stenger, Paul Teal, Paul Seish, Randy Lee Wright, Raymond Hill, Roger Stenstrom, Ronnie Box, Sal Marandola, Scott Lefgren, Terry Wright, Tim Mazza, Ted Glendy, and William Arcand. So what happens when trunk systems fail? Where do the users go? How do they know where to go? How do they communicate? Well, let me break down something that I've seen and heard with my own eyes and ears in that order. A couple of years back, maybe a decade or so back, before my local police department went encrypted, they were simulcasting on their old analog UHF channel. So they were fully operational on the trunk system, fully set up with their encrypted talk groups, 100% on the new system. for some lucky reason, we were still able to monitor them on their old UHF channels for quite some time. I'd say for a couple years we were able to do that until, the hardware started failing and somebody said, look, we got to pull the plug eventually. So once this system crashes, that's it. We're not going to bring it back up again. But we were able to hear what was going on the old analog system. So I'm listening around one of these days and we start noticing that it's looking kind of quiet, right? And of course you think to yourself, great, here we go again. They pulled the plug. Things are quiet. We're fully encrypted now. That's it. Fun's over. Party's over. Time to go home, right? Or you don't have to go home, but you can't stay here, right? Those kinds of things. So I don't remember at the time if it was Unitrunker or if it was Pro 96 COM that I was running, but I was taking a look at the trunk system and I started noticing that there were a lot of rejects or denials on the system from radios when they would try to join a talk group. Now, again, these are all things you can see when you look at a control channel through software like Unitrunker or DST Plus or anything on the market right now that watches these control channels and spits out the information. And we were noticing that there was just a ton of denials, a ton of rejects, and it looked like this system was just going into meltdown mode, like it was just failing. And every radio was just blowing red, right? The whole system was just blowing red. You didn't see any voice traffic, and then you would see a little bit show up, and then it would die down again. And it was bad. Like you just looked at this thing, and it was just scrolling by rapidly. You could tell, like everybody was just trying to turn the dial on their radios. This system went into like a full meltdown mode. There was just nothing happening on this system. And I think it broke to the point where it actually failed hard, because that's not the way that these systems are supposed to operate. Eventually, you would hear a dispatcher come on the air say, all units, please call in on your cell phones. So we now know we had a full meltdown of the communication system on that trunk system. Now, we all know heads would have rolled from Motorola, right? Because it was a Motorola-based system. And it shouldn't have happened. It should have gone into what they call a Failsoft mode. And we're going to talk about a Failsoft mode. But the system just went. It went toes up, denied everybody, denied everything. Now, it's a good thing they still had the analog system. If they had to roll everybody back over to it, they probably should have rolled everybody over to it instead of saying, jump onto your cell phone, give us a call, right? There's protocols in place, or there should be protocols in place. And I'm sure since then, there are now protocols in place as to what to do when a system goes onto full nuclear meltdown like that. But it was very interesting from my point of view, from here at my computer, to see the entire network melt. Just like I said, go toes up. And you hear what it did, right? It was pure pandemonium and panic. You could hear from the dispatchers coming back online. Any unit that reads us, call in. Use your cell phone and call in. So how do end users actually know that their radios are not going to be talking to the network? How do they know that the system has failed? Because an end user needs to know this, right? They just can't just try smacking that push to talk button and praying that they can get out there, right? Their radio is going to need to tell them, like, hey, something's wrong here. Something is bad. We need to work on this, or you need to do something to mitigate this situation here. So like I said, Motorola has got a trade name called Failsoft. I'm sure Harris has the same thing with their trunk systems, but I just don't have the details in front of me right now. But when a trunk system goes into an operation and it fails, and there's a control channel that is no longer present on the system is supposed to go into this Failsoft mode. So before we get into Failsoft mode and what happens here, let's talk about how a trunked radio system actually works. We'll do a quick primer, a quick refresher to those that just think that it's magic how it works and they don't really understand it, but we'll go through everything here. So what a trunk system is a pool of frequencies, maybe 6, 10, 12, 20, right? Whatever it takes. And every user on the system, every subscriber or every radio user, which you call a subscriber, is grouped into groups. So think about it, you have a police department. but maybe you have a dispatch for each precinct in the police department. In my neighboring county, that's perfect. In my county, they've grouped two precincts in a single talk group. New York City does it differently. Some areas just do a north, a south, a west, right? It all depends. But what you have to remember is we have groups of subscribers, or groups of end users, groups of radio users. That group is your talk group. And what happens is that talk group, or all those radios on that talk group, are listening to the control channel. So is your scanner, by the way. And it's waiting for the control channel to tell that group what to do and where to go. See, we have a pooled resource of frequencies on the system. These can be used as alternative control channels, or they can be used as voice channels. Now, these alternative control channels can also be used as voice channels as well, depending on, right, I believe, depending on how things are set up. So what ends up happening is we listen to the control channel. The control channel is going to say, hey, police department, go over to channel 5. And because we know the band plan, all the users who are listening to the control channel that are looking for that talk group then go over to channel 5. We hear the conversation on channel 5. As soon as that conversation is over, the radio dekeys. We all go back to the control channel and listen for the next instructions from the control channel. A user in the field may respond back to that dispatch. He keys up the radio. When he keys up, over the air says, "Here's my radio ID. I need a talk group. I need a radio path. I need a voice path." The control channel will say, "Go to channel 7. Everybody in this group go to channel 7. Everybody in the police talk group goes over to channel 7. The unit responding back to dispatch says what they have to say. They dekey the radio, and we all go back to the control channel, waiting for the next instruction. In the meantime, because we were already on 5 and we vacated it, somebody else got assigned channel 5, which is why we couldn't go back there. We had to go to 7. Now we're on 7. We left 7, went back to the control channel. In the meantime, the fire department is also on. They might have just grabbed channel 7. So now we need to go somewhere else if we need to respond. So again, dispatcher comes on with more information. They key up the radio. Their radio says, "Here's my radio ID. I need a voice channel." The control channel says, "Okay, well, 5 and 7 are busy. You can go to channel 2." Now we all go to channel 2 as a group. Once that conversation is done, we all go back to the control channel. Our scanner does basically the exact same thing, except while it's sitting on the control channel, it is looking for all these talk groups that we have in our scan list. And when it sees that voice grant come over the control channel, our scanner goes to that voice channel that the controller is telling that group to go to. That, in a nutshell, is how trunking works. There's a little bit more behind the scenes, but for a high-level view on what we need to understand as far as how our scanner radios work, that is how a trunk system works. So what happens now when that controller fails? It goes to sleep, goes toes up, it goes 6 feet under, right? Now, all of a sudden, we don't have our conductor, right, telling us where to go. Well, if that radio fails, we would hopefully have the alternative control channels kick in and resume control of the system. But we have other points of failures that can happen here. We can have failure of the central controller. We can have failure of all 4 control channels. We can have a failure of all the voice channels on a system. That's basically when a site just goes, boop, gone, done. Well, when we are in Failsoft mode, a system acts as a conventional repeater system. And what ends up happening is the system sends out a beacon or a tone that's read by the radios, and the radios then know that the system has lost its brains, lost its conductor, lost the control channel, and is now in Failsoft mode. The radio will then drop back to a designated frequency that it has been pre-assigned to for that talk group. So basically, the radio knows what talk group it's on and the channel it should go to, or the frequency it should go to. If you turn the dial and you change your talk group, you may be assigned to a different frequency. Again, that's all part of what's in the subscriber radio. Now, what's in our scanners? Now, our scanners don't go in the Failsoft mode. We would actually have to program in these frequencies as a conventional repeater to go into a pseudo Failsoft mode in our scanner. But this tone that goes out over the air, that's read by the subscriber radio sends out an alert to the end user, a tone to the end user that they know they're in Failsoft mode, and the display on the radio will say Failsoft. This is how the end user knows that something's not right here. They also know now that they may be compromised, not compromised as far as, just getting traffic across, but they will also realize now that they're hearing a lot more traffic on their radios than they're used to from other users who they are not normally hearing from. For example, again, like I believe I said at the top of the podcast, my neighboring trunk system has got 9 frequencies assigned to the site and 122 talk groups being shared on that site. Which means if you do the math, right, you've got 9 frequencies and you have 122 talk groups, there's going to be quite a bit of talk groups sharing an assigned frequency. So this is a way around when it starts to fail, your radios know where to go. Communication can still happen, right? All these voice channels, should they still be in operation, turn into conventional repeaters, and you can still communicate. Now, what you would expect to find is that maybe on frequency 1, all the police departments go there. Frequency 2, all the fire departments. Frequency 3, all the medical radios. Frequency 4, maybe the county buses, right? Frequency 5, maybe, I don't know, something else shows up. The DPW is something, right? So that you still have bits and pieces broken up, right? You still got police with police, fire with fire, EMS with EMS, but the system's a mess now. Now, on the other side of the break, we're going to talk about more features of how things work, some backup plans that you may find out from your local agencies and how to find that information as well. And as a reminder, anybody who is a $3 more a month Patreon supporter does not get this break. If you want to help support the podcast, go to scannerschool.com/Patreon to help us and support the podcast. For everybody else, we'll catch you right after this break. Hey, did you realize it takes us almost $100 a week just to have this podcast episode professionally edited and sent over to you? This doesn't even include website and podcast hosting, administrative help, and other monthly subscriptions that are required to put the podcast out there. Now, you can help us offset these costs when you shop online. So if you're looking for a scanner radio or some software, looking to bid on items over on eBay, or if you're looking to purchase anything, and I mean anything, on Amazon, you can help support Scanner School in the process, and this doesn't come at any extra cost to you. So please check out scannerschool.com/support for the multiple different ways that we have out there that you can help support us when you shop online. Again, scannerschool.com/support. Are you looking to learn more about the scanner radio hobby? We currently have courses on how to get started and up and running with software-defined radios and how to turn your SDR into a fully functioning scanner radio. With free software, you can see more and do more with trunking than ever before. And with new courses scheduled for the upcoming months, our offerings will be expanding into both Uniden and Whistler hardware and software. Check out our courses at courses.scannerschool.com or by looking for the link in this podcast description. National Communications Magazine is your personal library of scanner, CB, GMRS, FRS, MURS, and two-way radio articles written by the best minds in the business over the past 3 decades. Your NatCom personal online access account allows you to download the newest issues of America's hobby radio magazine, as well as back issues too. Visit natcommag.com to download your free sample issue and sign up today. Did you know that a pager can make a great addition to your scanner radio collection? And even if I didn't own East Coast pagers, I still have one or maybe a couple of pagers as a part of my scanner radio setup. This is because a pager can be used to just monitor your local fire department or your regional departments, and if you set it up correctly to alert you when the tones are sent over the air, then the pager will remain silent until you need to know what is going on. This frees up your scanner to monitor everything else that's going on besides your local stuff, or can prevent you from missing the local stuff because your scanner is busy doing other things. Now, pagers aren't just limited to fire dispatches anymore. Unication has great solutions to monitor both analog and P25 paging systems, where many public safety and police departments are switching over to. Swissphone and Apollo make great analog solutions as well, and all three still sell POGSAG and Flex pagers, still in use by many departments for text alerting. East Coast Pagers is an Apollo, Swissphone, and Unication dealer serving the North American market, and of course is one of my online companies. So if you're looking for a personal use pager or one for your department, contact us for a free quote and let us know you're a Scanner School listener for something a little extra with your order. For our full inventory or to request a quote or just to contact us, please visit eastcoastpagers.com. All right, so before the break, we talked about the different ways that a trunk system could fail, right? And the different methods that we have, right? Go back to Failsoft mode and also where the radios are supposed to go based on their talk group assignments. These frequencies that they fall back to are pre-programmed in the radio. That's the key here, right? Our scanners don't know what these assignments are. They are set up in the radio by the radio company, right? Or the radio group that programs these radios. So like I was saying before, we would need to set up a Failsoft system in our scanners if we wanted to continue to scan these trunk systems after Failsoft mode. Let's break down the different categories of failures that we can have on a trunk system. So the normal operation is wide area trunking. That's basically the day-to-day operation of a trunk system. Now, wide area trunking would mean you have multiple trunk towers or see, here's the problem. In radio reference, we talk about sites, and sites can be multiple transmitter locations. And here's where we have to unscrew our brains a little bit. When we have a trunk system, especially in simulcast, we have multiple trunk towers and multiple transmitter locations, all operating at the exact same time, the exact same information, and that is basically a site. Now, one of these towers can go offline, right? That's fine. We'll have a degradation in coverage. But as long as we have the majority of these transmitter towers or transmitter locations up, the site itself, the simulcast site, the simulcast system will continue to operate. Now, if we have a master site loss, individual RF sites will then enter into site trunking mode where users connected to that site will all be grouped together and will not be able to communicate with surrounding sites. Okay, that means basically each site becomes an island. Also, wireline consoles will not function, but consoles will be able to communicate through a backup radios in dispatch. So they'll have to grab a backup radio in the dispatch center to talk to these different sites. So again, we can lose the entire network, we can lose just one site, or we can lose sites and become island sites. Then we've got Failsoft. Failsoft, again, is the complete loss of trunking capabilities that will cause all of the radios to fall back to a conventional channel and the system to operate as if it was a conventional repeater. Each frequency is grouped based on the talk group, the frequency predefined in the radio, as we said. Now, this is all good and dandy, right? At least now we have a way that the radio can tell the end user, hey, I'm in Failsoft mode, something happened. The system can then assign these radios, these talk groups, to a frequency. Actually, it doesn't happen that way. The radio already knows I'm in Failsoft mode and I need to go to this frequency because the system is dead and can't tell me what to do. But what's an alternative here? What's the backup plan? What happens when this all fails? What happens if we can't even get into Failsoft mode? What happens when everything goes down and there is no beacon that says, hey, go to Failsoft? The units are, now you have all these field units out there that are just out of range, completely out of range. The radios are out of range because there's no control channel. There's no Failsoft beacon. There's nothing. Well, a good system administrator would have thought of that already and would have put in their radios, in all the subscriber radios, a backup zone. All users would have been instructed when they went through radio school or were issued a radio that if everything fails, to go into the backup zone. And the backup zone is going to basically be alpha tagged and would say law, fire, highway, schools, jail, whatever, on each one of the positions on the knob. And you would just turn the knob to your backup position, and that's where you would go. It may just be a simplex frequency at that point because everything is dead. There's no towers. There's no repeater. There's no system available. But the end user would know where to put their radio because they would have been trained to have done so. Maybe the dispatcher has an SMS or a text message-based system that they could send out to all the police department units and say, radio failure, turn to backup zone channel 2. Right? Maybe that goes out via SMS. I don't know. I'm not in public safety. I'm just a scanner radio user. But a good network administrator would have thought of that and would have put that into the radios. Now, how do we know this? How do we find this out? It's pretty easy. If you go onto Google, you can actually put into a Google search your county name radio presentation or your county name trunk system presentation or something like that, right? You'll be surprised at what you can find. I actually found a couple of these where when they were moving over to a new system, basically either Motorola or Harris comes in or somebody from the two-way radio shop that's reprogramming these radios. Somebody's under contract to come in and basically put on a presentation to the brass or to the end user to say, here's your new radio. This is how your new radio works. And I'm sure this is a presentation that's probably issued with the radio as far as, a paper version of this. The slides that go along with it. Because again, it would be a picture of the radio and it would say, here's where you change the volume. Here's where you change the frequency. This is where your antenna is. This is where, you push the talk button is. This is how you move up and down the zones, right? These are what each one of these buttons do. This is your man down button or your emergency alert button, right? There's going to be a spreadsheet or a presentation, not a spreadsheet, but a presentation basically or a pictorial diagram that shows the end user how to use the radio so that they're given this tool, right? Because the radio is a tool in the field. They're given this tool and they know how to use it. Now, part of that documentation should be what to do when things fail. Now, all the information in this podcast episode pretty much came from one of these presentations I found online, where I found out that, this is your radio is going to say Failsoft when it goes under. Your radio is going to say out of range when there's no more control channel, right? This was all in that presentation. So Google it. You'll find pretty much if you have a brand new system or a relatively new system in your area, you may be able to find the presentation that was given to the end users or handed out to the end user when they were issued their brand new radio to go on to the new system. So remember, a trunked radio system is a pool of resources. And all of these groups are sharing the voice channels when they're not in use. It's a great form of radio or spectrum efficiency. When a trunk system fails, and it could fail for several reasons, whether you lose one tower, which is fine, you just have a degradation in coverage, or you can have towers or sites that become islands, again, still functional, but you can't roam out of a tower. You can then go into Failsoft, which basically means that your radio knows that a failure has happened and will fall back to the designated conventional repeater channel or a voice frequency that becomes a repeater channel. Or it can be just completely dead. And at that point, the radio will say out of range. You'll need to then take your radio, or the user would have to take their radio and put it into the backup zone. And then again, that would be one of the frequencies that would be set up for backup zones. Now, again, as a scanner radio user, we don't have any way of following what the fail-safe protocol is or the backup protocol is. So again, it would be wise to actually just have a set of frequencies, basically the frequencies from your trunk system, set up as conventional and run that as a backup zone just in case things fail. I haven't really played around this because I haven't noticed any other systems go in the fail-safe mode, and whether or not, right, your scanner would continue to work. Because again, it's going to look for the control channel. And if there's no control channel present, would it stop on a voice channel? Probably not. It would need to be in conventional mode. That's what I'm betting. But if I'm wrong, I would love to know. Educate me. Jump into our Discord server and let us know. If you are a system administrator or you work for a radio company and you've got a little bit more information about it than I do. Scannerschool.com/Discord is how you can join the conversation about this podcast episode. Don't forget, I need your questions too. you can call me now, 516-308-2885. That goes straight to voicemail, by the way. So you don't have to talk to me. It goes right to voicemail, and I'll play the voicemail on an upcoming Ask Scanner School session. And again, if you leave me a voicemail or use our SpeakPipe method over at scannerschool.com/ask, I'll put you in a ring for a free tutoring session. And if you need help and you want to book me for tutoring, you can go to scannerschool.com/tutoring. We will catch everybody next week. Thanks again for listening, and please share the podcast with somebody that you think would benefit from this podcast episode, because that is how we can hit our goal of teaching as many people as possible about the scanner radio hobby. My name is Phil Lichtenberger, and this is Scanner School. We teach you everything to know about the scanner radio hobby. Thanks again for listening. Make sure you subscribe, and catch you all next week. 73.